So this can be written as V time dt. Okay. So now I'm going to just rearrange this. So this can be written as Q. I'm going to insert this V here. Okay. E dot V, because here we are having the dot product. E dot V plus okay. So E dot V, and here what we have already, V curl of B, again the dot product of V time dt. Okay, so from this one we can say that the dw is equal to and also we know that we have a the say vector here, and the same vector is having the divergence of the curl product, so this will be equal to 0. Therefore finally we can have that electric field and also the velocity of that charge time dt. So from this one we can say that the dw over dt is equal to q E dot V. Okay. Okay. So here the charge is given as Q. We know that we can connect this charge with the charge density. Now that means the for particular volume. So if we connect that with the charge density, the total charge will be equal to the integration of charge density for that particular volume of tau time d tau. So this is the possible way to get the total charge. So now we are going to apply this idea here. Okay, so instead of the total charge Q, I'm going to replace this volume charge density or the charge density. So that can be written as the integration of tau. So carefully follow my steps, and I'm just giving that reason why we are having that next steps and here, okay, that on that right side. So just have that idea about that. We just recall them. We already knew them. Just recall here. So this can be written as rho time d tau. So I'm going to arrange in a order. So I'm going to just having this V. Okay, I'm just writing here V divergence of E time d tau. Okay. So now we can say that the integration of the rho into the velocity. We can say that the rho, the charge density time the velocity is equal to J, the current density. So now we can apply that idea here. So this will be equal to current density time the electric field of d tau. Okay, so say that this is our first equation. So now by just keeping this first equation, I'm going to work with that Maxwell equation. Okay, so just give me some time to erase this, the top thing what we already written. So I hope you all have written this. So I just delete them, okay? Okay. So we will use that one of the Maxwell equation which is given by the curl of B, the cross product of B. So curl of B is equal, our original equation is mu naught time J plus mu naught epsilon naught dabba E over dabba T. So, so from this equation, can you find what can be the J? Can you just take out J this side and other things are other side? Can you do this? So J can be written as 1 over mu naught, this one, going the other way, curl of B time minus epsilon naught dabba E over dabba T. So I hope you also got the same. So now what is J? In our equation, so this is dw over dt. So here we know that we need J, the dot product of A. So now if we know the J, we can have that the dot product of electric field. We need to multiply both sides. So we can write this as 1 over mu naught time the divergence of, sorry, the dot product of electric field time this one, curl of magnetic field minus epsilon naught and electric field dot product of dabba E over dabba T. So this can be written as, now I'm going to have this the integration with respect to this the dTau for that volume element. So if I just write this integration for the volume, J dot E dTau, and I can do the same thing on the other side also. So integration of for the volume tau for this 1 over mu naught E time curl of B minus epsilon naught E time dabba E over dabba T for that volume element. Okay, say now this is our second equation. And we know that if we have a triple product, one is that dot product of curl. We know there's this mathematical expansion. So, okay, give me some time to change this color. Okay. So, for example, if we have three vectors, say A dot B cross product of C, then this can be written as C time the vector of A cross B minus B time A cross C. So according to that, if you have this idea, can you find how can we write this electric field, the dot product of the curl of B? Can you expand this term using this idea? Please let me know your answer once you got it. Okay, so I hope you have written the expansions of E dot curl of B. So here, this might be the answer for that one. So I just substitute instead of this E dot sorry, curl of B here, and I just write these the remaining things here. So we can say that this is the equation number 3. Okay. So now we will use that fourth rules, or the fourth maybe or third rule of that Maxwell equation. What is that? Where we started with the magnetic field. Now we will use the idea for the curl of electric field. So in our equation, curl of electric field is there. So from this Maxwell equation, we know that curl of E is equal to, so this is equal to dabba B over dabba T. So now we can just replace that instead of this curl of B. Okay. So from that one, what we can say, so I just write here. Okay. Okay. I'll change the color. Integration of T dot E T2 is equal to integration of this should be equal to minus 10 dabba B over dabba C. So we can have that 1 over mu naught B here dot dabba B over dabba T, and also minus here. So I just write on the minus here. Okay. Minus time the electric field cross magnetic field. And here this will be that the B dot 1 over mu naught will be common for both two terms. So I just substitute here and expand that. So 1 over mu naught here also I wrote as a 1 over mu naught minus time this remaining term epsilon naught E dot dabba E over dabba T time d2. Okay. So so we can just continue the remaining things on the top. I hope you have written that. Can I erase? Can I? Physical Science 102? Physical Science 102? You're not there? Physical science 83.
Yes, ma'am.
Okay. Can I raise them? Have you written? Okay, thank you. Now I'm just going to rearrange that. So write down the same thing on this side, left side. I'll continue the right side only. Okay. So I'm going to have that minus notation outside because all having the minus notation. So I'm going to have that minus the integration of 1 over mu naught time b dot dabba b over dabba t plus I'm going to arrange this one close to this term. I'm going to write down the second term here as a third term, okay, for the easy purpose. So I just rearrange it according to this. E dot dabba E over dabba t plus 1 over mu naught divergence of curl of B time d2. Okay. Okay, and now I'm going to raise that downside also. I hope you have written already, so we can continue there. So here what we have, integration of j dot e for the d2. Now we can just cancel the terms, but we have integration of d with respect to d2 here, and both side we are having that, right? So now from this one, what we can say, j dot e is equal to minus time what 1 over mu naught b dot dabba b over dabba t plus epsilon naught e sine dabba e over dabba t plus 1 over mu naught the divergence of so I missed this one. It should be E, right? No one corrected me. This should be E. E cross B. Okay. And also there's the magnetic energy or this electric energy can be written in the format of B dot dabba B over dabba T is equal to half of B square. Dabba over dabba T B square. So this can be equal to half of this one. Likewise, the magnetic field E dot dabba E over dabba T can be written as dabba over dabba T for the electric field scared. So now we can just substitute both of two here. B dot dabba B over dabba T and also E dot dabba E over dabba T. Therefore, we can obtain that J dot E is equal to minus half time dabba over dabba T. Here, but we have mu naught here and here epsilon naught. So we can have that b squared over mu naught plus epsilon naught e squared minus 1 over mu naught divergence of the cross product of E and B. Okay, and also in our first equation, we know that, okay, I just write here. dw over dt. In our first equation, we have that dw over dt is equal integration of j dot e time d2. And now we know that in our previous step here. So this is equal all of these, right? So can you just write down? Can you just replace this? What we have here? So now we found that this one. So if we get the integration of this one, then that will be equal. So can you just write down these all here? Okay, so just replace these things here. This all together. Okay. So here we can, I hope you all have already written this. And also now we are going to use the divergence theorem, okay? Using divergence theorem. The divergence theorem is telling that the integration for the tau, okay, integration of the volume element, if we have the divergence of that cross product, or the what we say as a triple product for the volume element, according to the divergence theorem, this can be written for the surface element, surface element. Then what we have after the divergence, this curve. So what we have here, E cross B. So this can be written as E cross B for the surface element. So this is the divergence theorem. So now we can just apply this one where we have divergence of this one. So in this place, we can use the divergence theorem. Then this will be changed as the for the surface one. Okay, if you just substitute these things in the previous equation here, then you will be get that dw over dt is equal the integration of minus time daba over daba t.
Kochajan. 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 பொறுங்க அவங்களுக்கு அறிவா நடக்குது எந்த பக்கம் தூக்கிட்டு போறேன்ட்டு இங்க பார்க்க போனாங்க
Physical science 04. Physical science 04. So not close to the mobile, I think. Okay, so now it's okay. So we can have that d2 minus time, the surface element of 1 over mu naught E curl of B, E, the cross product B time ds. So this is given as the Poynting theorem, the work done for particular time of the electromagnetic field. That means we have the external electromagnetic field that can be written as the doing work per rate, or the rate of work is equal to this one. Okay, this is saying as Poynting theorem. Okay, So now there are two terms. So let's see what are the meaning of these two terms. The first term is this one. Okay, first I just raise them. Okay, can you please write down this first term? This one. Okay, who needs to join for the prayers? You can leave. So now write down this first term, the volume element, and write down the meaning of the first term, which is the rate of total energy rate of total energy stored total energy stored in the electromagnetic field. Total energy stored in the electromagnetic field. And the second term, this one. Can you please write down this second term? So this is given as the rate at which the energy rate at which the energy is carried out of volume tau across the boundary surface S across the boundary surface S by the electromagnetic field Okay, write down in the next line. The pointing theorem says that the work done on the charge by the electromagnetic force is equal to degrees in energy stored in the field. We are having here minus notation, so this will be decreasing one. The degrees in the energy stored in the field less the field less the energy that flowed that flow out through the surface. Flowed out through the surface. Okay, so here we just having that half of that energy. So if we have the electromagnetic field, then the energy density. So that energy density means, so this one. This product should be multiplied by the time. So this can be written as, give me some time to raise that. Okay. So the electromagnetic energy density is equal half of that epsilon naught E squared plus beta squared over mu naught. So this is what we say as a half time of this one. We say as the energy density. And the notation normally we use U of electromagnetic field. Okay. So write down next line. The energy per unit time. The energy per unit time per unit area per unit area the energy per unit time per unit area transported by the field transported by the field transported transported by the field is called pointing vector. Pointing vector. So we normally use that notation as a S. So this pointing vector can be written as 1 over mu naught and the cross product of the electric field. So this is what we say as a pointing vector. So we can just make it as that bolted one. If not, we will use as like this. Okay. So this S is the pointing vector. So now, so we can rearrange that the dW over dt or the rate of work is equal to what we already obtained J dot E time d tau. So this can be written as integration of minus time integration of tau, and we know that this is equal to the energy density, and we are having the dabba over dabba t. So dabba over dabba t times the energy density of electromagnetic force plus, and I got the minus outside for both of them, so we can have the plus value of the divergence of the cross product of electric and the magnetic field. Tito. Okay. Okay, under this equation, can you please write down that the work done per unit time, the work done per unit time, per unit volume, the work done per unit time, per unit volume by the field, unit volume by the field, J dot E, by the field, J dot E is the is the conversion of electromagnetic energy into mechanical or heat energy. Mechanical or heat energy. In next line, since matter is matter, since matter is ultimately made of charged particle, ultimately made of charged particle, made of charged particles, comma, we can interpret we can interpret the pointing theorem. The pointing theorem we can interpret the pointing theorem for the microscopic field. For the microscopic field, that means both having that electric field and the magnetic field. Okay. Microscopic field as a statement of conservation conservation of energy of the combined system of the particles of the combined system of the particles and field. So in next line, if we denote that the total energy of the particles within the volume tau as E mechanical energy. So we can say that mechanical energy as a E mech. Okay. And we know that this can be possible to have the mechanical energy and also the heat. So if we say this, this is the mechanical energy, so we can say that the mechanical energy, because we know the dW over dt. So here what we say, the energy is equal to the mechanical energy. So we can say that E mech over dt will be equal to the integration of, J dot E d2. Okay, so now already we know that this can be as written as minus time half of dabba over dabba t epsilon naught E square sorry for the inconvenience. So this will be equal to half of dabba over dabba t epsilon naught E square plus B squared over mu naught time d2. And also another term is there. Now we have introduced the pointing vector. So now we can now replace that. That term is equal to the integration for the surface element and also the pointing vector of along the surface. So here we can write down that S dot the unit vector. Okay, the direction unit vector is equal to the length of 1. Therefore, it will be having no change. It will be magnitudely is equal to the S value, but along the N direction. Okay, so now this can be written as, this is the mechanical energy, but we already defined mechanical energy density. So this can be written as the differentiation of, because we are having the dabba over dabba t, so that can be written as the E field over dt minus the integration along the surface of the pointing vector along this unit vector time ds. So this can be written for the mechanical energy, and that the total energy is the combination of mechanical energy and also electric field energy. So from this equation, now what we can say, can do that like okay, from this equation we can say E mechanical over dt, and if I have this term other side, this will be equal to et for the electric field. E field is equal to s dot ds. Okay, now if I have this d over dt as a common one, and inside that we can have that mechanical energy plus E field is equal to this one. Okay, so this is equal actually the divergence of minus time the divergence of S. Okay, so if I have this one on this right side, sorry, left side, then I can make it as a plus notation. So, and if you need, you can write it in next line and just replace here. So this can be changes plus is equal 0. So this is the conservation of that energy conservation. The total magnetic field rate, because it's divided by the time, the energy rate plus the divergence of this pointing vector will be equal to 0. Okay. Okay, so I think the time's up now. So these are the things we needed to cover under this that electromagnetic theory mostly, and I just skip some of the part because it having that very deep mathematics and sometimes maybe a little bit difficult for that as a that general degree students. Okay, that's why I just skip them, and this is highly enough to have that basic idea and that better understanding of the electromagnetic field and how can we just use the in our practical life. So what I hope that in next lecture coming Thursday we can conduct the